In this video, we're going to develop a formula for A cross B. So we'll pass through a few slides here. And we want to imagine A is A1, A2, A3, and B is B1, B2, B3. We're going to let the vector v equal x, y, z such that A dot v and B dot v equals 0. Well, if A dot v equals 0, then A1, A2, A3 dotted with x, y, z is 0, which means A1x plus A2y plus A3z would be 0. Following a similar process with B dot v equaling 0, we'd get B1x plus B2y plus B3z equaling 0. So we have equation 1 and equation 2 there. Okay? Now, we're going to use the process of elimination. We're going to see if we can get the same coefficient in front of x in both of those equations. So we're going to multiply the entire first equation by b1 and the entire second equation by a1. And if we do that, we get this for the first equation, and we get this for the second equation. We're just using the method of elimination. We can then subtract equation 2 from equation 1. And when we do that, a1b1x minus a1b1x, they're gone. And what we get is a2b1y minus a1b2y. And then we get a3b1z minus a1b3z. And we get 0 minus 0, which is still 0. Okay? So we have that equation right there. Well, we can throw a couple of terms on the other side. We can throw that term onto the other side and throw this term onto the other side as well. And we would get the equation that you see written in the second line. Now, we're going to multiply both sides by -1 at this point. And when we do that, we get a1b2y minus a2b1y equaling a3b1z minus a1b3z. We can factor y out of the left-hand side, so y times a1b2 minus a2b1 will equal z factored out and then multiplied by a3b1 minus a1b2. And that'll be the expression that we get. Now, what we're going to do is rearrange that just a little bit, okay? And we'll just put, all we're doing here is putting, instead of A2B1, we're calling it B1A2. And instead of A3B1, we're calling it B1A3. No big deal. Everything else is the same. Now we're going to divide both sides by the coefficient of y and by the coefficient of z. So what's going to end up happening is we're going to get y over b1a3 minus a1b3 is going to equal z over a1b2 minus a2b1. If it helps you, just imagine this. Imagine that at this moment we cross-multiplied. Y times this expression would equal z times this expression. Well, that's exactly what's written here. Basically, what we just did is the opposite of a cross multiply. And we got it back to what it would be in the step prior. It's like working backwards from what you often would do. So we have that expression circled in green at the bottom. That's a very important expression. Now, like it says on the next slide, if we followed out the exact same procedure, but instead of eliminating the x terms, we eliminated the z terms, we'd get the equation circled at the bottom there. Now, just notice something. On the previous slide, we have y over b1a3 minus a1b3, and here we have y over b1a3 minus a1b3. Okay, we have y over the same expression in both cases. So really what we've got is, in the first case, we had x over a particular denominator equaled y over a denominator. And in the second equation, we had y over that same denominator equaling z over a denominator. So putting it all together, they must all equal each other. So they all equal each other. Now, we're going to let those values be k. Let k be the value that all of them are equal to. Okay? The vector xyz, if you recall, is just a vector perpendicular to the vectors in the equation, so the vectors given in the question. And so we can let that vector have any magnitude we want, because in essence, we're just concerned about the fact that it be perpendicular. So we can let it have any magnitude and not affect its direction, and thus ultimately its perpendicularity to A and B. So we're going to let k have any non-zero value. Let's let k equal 1. Now, if we let k equal 1, then that means all of these fractions have numerator equal to denominator. A fraction equals 1 if its numerator and denominator equal each other. So that's like saying x must equal a2b3 minus a3b2. It's like saying y must equal a3b1 minus a1b3. And it's like saying z must equal a1b2 minus a2b1. And so what we get is our, we said earlier that xyz would be perpendicular to each of the vectors given. Well, that xyz is really a2b3 minus a3b2, a3b1 minus a1b3, and a1b2 minus a2b1. And we have a formula now for A cross B. Okay, and then we're just going to skip through the rest here, because we won't need it, because for this video we were just trying to establish why that formula was come up with.